Welcome back to Flash Tracks Woodworking. Today's video is a little unusual in that it is intended to be used for training for some Habitat for Humanity co-workers interested in CNC machining. We'll be covering all the basic steps needed to complete a CNC project, including drawing a part using Vectric VCarve desktop software, creating Toolpaths using the same program, and then setting up and machining the part using this Next Wave Automation Shark 2 CNC machine. The part we'll be creating is this small wooden key, sometimes used as part of new home dedication ceremonies at Habitat. The key is a common symbol and metaphor for partner families unlocking their potential to a better life through affordable housing. So stick around if you're part of the Habitat training or just want some basic information on how to complete all the steps in a CNC project.
The objective of this video clip is to show the creation of this Habitat key that you see here in this rendering. I'll be showing really only the steps necessary to form the key, not going into much other description about the various different features of this VCarve desktop software. I will show all the steps to create the outline and also show the importation of the vectors for this logo, since that part of the artwork already exists. Now let's see what it would take to create a key from scratch. I will park a rendering of that key that we're trying to make down in the lower left corner, but we'll use our Vectric VCarve desktop software and show all the tools necessary to make that key from scratch. So we'll create a new file. It'll be 4 inches by 4 inches by 0.205 inches thick. Say OK. Brings up a palette for us to work in here. First thing we'll do is we will draw a rectangle, which will be the outer periphery of the key. And that key is going to be 1.1 inches wide and 2.5 inches tall. Create that. Now we want to put the angles on the top and bottom, so we'll close our rectangle tool and just go to our simple line tool. Start at the midpoint at the top, drag down, and you can see the angle changing, and it'll snap to even intervals like 30 degrees. If we move off of it and hit spacebar, it'll stop the line. We'll create another one, click on the midpoint, drag down, go to 30 degrees, click, hit spacebar. Do the same thing on the bottom, midpoint on the bottom, drag out 30 degrees, click, move off, spacebar, click on the middle, go to 30 degrees, click, move off, spacebar. Okay, now we're going to close our line tool and we'll pick our interactive trim tool just to do some cleanup here. And we'll remove these pieces on the end that we don't need anymore. So let's get rid of those. And now we have sort of something a little bit closer to the outer boundary that we're looking for. Next, I'm going to create just a construction line, and you'll see what this is for in a second. So I'm going to click on this point here, drag out to the left, click off of it, and that's a height that I'm going to want to use here a little bit later. So next, let's form the house-looking portion of the key, another rectangle, and its width is going to be 0.9, and the height, not sure yet, maybe 2.5 is not bad. We'll trim it as we need. So let's create that. Yes, okay, that's taller than I wanted. Actually, I want this to be 0.55 tall. So close that, get rid of that one that I made by mistake. Now I want this house portion to be up underneath of the roof. So I'm gonna, by clicking on this rectangle and then holding the shift key and clicking on this line, I'm going to align the top of this rectangle to this line by choosing one of these alignment tools. And there it is. I still, however, want to create a bit of an eave to go on this house. So I'm going to move this rectangle down just a bit. So I'll click on it, use the move tool, move object, relative, in the Y direction, minus 0.1 inches. Apply that and close it. I don't need this line anymore. I'll delete it. I do want to extend this line over to the outside, so let's zoom in a bit there. And we'll go to our line tool, click here, go to the outside, release, hit spacebar. Do the same on the other side, go to the outside, release, spacebar, close. So I got a couple of extra pieces here that I don't need, like this top line. So go to my trim tool and trim that piece off. Actually don't need, well, that'll delete too much. Let's not do that yet. Now the long key part that has the teeth in it will be another rectangle. So let's open up the rectangle tool. That one is going to be 0.5 inches wide. And the length I'm going to be trimming later. Let's make it 2.5 for now. So create that. It has some extra pieces I don't want. So we'll go to the trim tool, trim this off. This. Now I believe I can trim these outside pieces off. There we go. And this piece here. So now I have the outer boundary of the key that I want. I just need to put the teeth in on one side. So I'm going to zoom into this area down here. And I'm going to use this line as the base or the bottom root for the teeth. In order to do that, when I click on it, I can see that it's connected to all the other lines as a vector. So I'm going to go in, hit the letter N for node editing, and I'm going to cut this vector here by right-clicking, cut vector, right-click, cut vector, then hit N again to get out of node editing mode. I'm going to click on that vector, go back to the move tool, relative in the X direction, minus 0.15 inches. Apply, close. Okay, so this is where I want the teeth to end up. So first I want to put a flat on the last tooth here. So I'll go to line tool, click on this point, come up until it reaches 0.06 inches, release, move off, hit the space bar. Then I will, while still in the line tool, I'll click on this point, come over that 30 degrees, move around 30, click off, space bar. Okay, close that. This line I don't need anymore. I'm going to delete that. And I'm going to take advantage of some symmetry about making a tooth out of these two lines that I've already drawn. So I'm going to click on both of these lines and I'm going to tell the software to connect them. So now that I have one vector out of these two lines. Next, I'm going to take those two lines and I'm going to mirror those with this mirror tool. I will flip horizontally and create a mirrored copy. So let's do that and close. You're going to see where this is going. So here's the second line I made is this purple one, and what I want to do is I want to drop it onto the tip of this one. So I've got the first line selected. I'm going to hold the shift key, click on the second line, then I'm going to use this alignment tool to drop that first line down onto the second one. So now I've made a full tooth on the end of this key. What I really need though is I need 4 more of these. Fortunately, I don't need to draw them all. I can take this set of vectors here and I can use a array copy tool, and I want 4 rows of keys and 1 column of keys, and I don't want any gap or offset between them. So let's just copy that. That took my 1 tooth, made 4 teeth out of it. Good deal. All right, next, just use our line tool and connect up to close the boundary. So now we've got the entire outline of the key that we wanted. Let's take a look here. I think we might have some open vectors. So I'm going to draw a bounding box around all of it. Use this tool that says join open vectors. It'll tell me that I have none are closed right now. I have 10 pieces parts that are open. So I will join those and make one complete vector for the outside boundary of the key. Next, we want to bring in the vectors for the logo the Habitat logo. To do that, I'll say File, Import Vectors. And I have an encapsulated PostScript file here, Habitat key logo. Double click on that one, and in comes the vectors for the logo. Click off of that, and that looks pretty good. Now we've got our key and our logo, and all that remains is to go over to the Toolpaths and create the toolpaths for the router bits to follow to cut this out of our material. What we're going to do is go over to the panel on the right and begin with our toolpath operations. So the first thing we're going to do is set our material and the movement of the router bit above the material. So let's see what we've got over here. Since we'd already entered 0.205 for the thickness of our material, which we measured with calipers earlier, that's already set. This XY datum is telling us that we're working from the center of the job. The Z0 is on the surface of the material. And these last sections down here are going to tell us how the router bit is going to move around between passes, between cutting passes when it does the job. So rapid Z gaps. So this 0.25 inches is how far the router bit is going to fly above the surface of the material as it goes from one cut to another. And then the home position is like the very start and stop position, and it will be at 0, 0, center of the material, and 0.8 inches above the material. Well, let's change it to 1 just to change something here. So okay, so there we go. So that's all set up. The next thing that we need to do is to create, I want to create this logo as a little pocket inside of the key. So we're going to create on that part of the artwork only, and we'll create a pocketed toolpath. So that's this second icon here. Let's pocket. Start depth is 0. We want to start at the surface. We want to go 20 thousandths deep. We're going to use a 1mm ball nose spiral end mill. That means it's 1 millimeter rounded radius on the tip of this fairly sharp end mill. That's all good. It's going to offset. It's going to move around inside of here in an offset rather than a raster movement. And we're going to leave these blank, and let's go ahead and at least name it. So we'll call this logo, L-O-G-O, and calculate. And there it is. So what it's showing me now is the blue here is all of the vectors, or all of the passes that the router bit is going to make to form this pocketed logo. You can see them here. Here's the heads, here's the bodies, and so forth. So we'll render that here in a second. So for now, that looks good. Looks like what we want. So let's close that. We'll erase that. Go back to 2D. It automatically went to 3D for us. So the next thing we want to do is cut out the outer periphery of the key, and we also want to cut this roof out with a hole all the way through, because this is going to be used to hold the key ring. So we're going to kind of double duty this roof object, not only as part of the art, but also as functionally to hold the key ring. So to do that, we'll go to a profile toolpath, and we're going to select the outer boundary and the roof vector. So we're going to go around it. So the start depth is 0 again on the surface. We're going to cut all the way through the material plus an additional 20 thousandths. So it says 0.235. If you didn't remember the thickness of the material, you can put a Z in here, and then you go plus 0.02 equals 225, excuse me, and that's how deep the router bit is going to go. Now I'm going to use the 1mm ball nose again. We're going to go outside of the vectors so that we leave this full geometry here. It's telling me it's going to take 3 passes to do that. We'll talk about tabs later. We're not going to do ramps, but let's go ahead and name this one cutout. Cutout, calculate. And now it gives me a warning message, says, oh, your material is 205, but you've told it to cut to 225. You're going to cut through the material, and if this material is sitting on the base of the machine, it's going to cut into the base. So we're going to put a spoil board in there so that that's not going to be an issue. So we say, okay, we understand that that's an issue. So now it's showing me that here's all of our vectors. We've got the passes that do the logo, and then the cutout passes that are here. While we're in this 3D view, we can go to Preview Toolpath. Sorry, I went by that quickly. So this icon here is Preview the Toolpaths, and then let's say Preview all Toolpaths. So it's showing the movement of the router bit, and it's cut into here, and then it's also cut out around that. If I want the logo detail to show up a little better, I'll go up here and change this global fill color to black, and then we see the bodies kind of filled in with black here. Also, if we double click on areas of the material that are completely cut out, double click on them, then it reveals just the key itself, and all of the excess material is then moved away. One other thing I want to show though is that one of the issues could be, let's go back to 2D view, is that as we cut this out, we really want the key to start rattling around in the pocket that's created there. So one of the things we can do is that we can go back to our cutout toolpath and add some tabs. So we'll come to this, we'll add tabs to the toolpath, edit them, and let's put a tab here and put a tab here, one sort of on either end, but on areas that are relatively flat, so they're easy to cut off with a chisel and then file down to leave a clean looking product. Close that, calculate it again. It's going to cut through, that's okay. Let's reset the preview one more time. Preview all toolpaths. And there we go. I'm going to straighten this up just a hair. Now, what you see is, you can see on the back side, or on the front too, if you look, you can see that it's still connected to the outside part of the material. This will keep the key from moving around inside of this pocket when it's completely cut out, and then having the possibility of the router bit taking a chunk out of the finished key. So that's useful. We've created the universal toolpaths at this point, but they need to be converted into a language that the controller for our particular machine will understand. So let's have a look again at the logo toolpaths, the folks in the center there, and then the cutout toolpaths. In order to save these, we'll use the Save Toolpath icon, which will bring up a screen as shown here in the upper right. We're going to select Visible Toolpaths to one file. What that means is, because we're cutting all of our toolpaths with the same router bit, both the logo and the cutout being cut with the 1mm ball nose bit, they can all be put into one file and be executed successively at the machine. It's important that we pick the correct post-processor. Again, these toolpaths need to be understood by our controller, so the CNC Shark USB ARCS inch star.tap, that is the post-processor that we want to use the router on the Shark 2. We say Save Toolpath, and it will take the name of the first item in our toolpath, but let's make it descriptive of both. So let's just say key for training, and it'll give it the extensions .tap, and we say save, and we're good to go. Clear those toolpaths, clear the screen, and we'll also copy that file over to a flash drive and then proceed to the actual CNC machine.
You can see we're now at the CNC machine. We've brought our toolpaths down on this flash drive, which we can insert into the left side of the pendant, which is connected to the control box. We'll go ahead and turn that control box on now. When we do that, the pendant lights up, gives us a welcome screen. We'll say continue, and then we'll acknowledge the warning that we're using a power tool. We brought along with us also this drawing that gives us some dimensions and some other information about the job that we're going to run, and a picture of the key. It helps us know where we're going to put our clamps and such, and just to verify which router bit we're using, and also which file we're going to be executing in this next phase. So on the pendant here, we have 6 buttons that control the jog movement of the router bit in the x-axis, which is across the machine this way, the y-axis, which runs forward and back this way, and then the z-axis, which runs vertically. So the first thing we'll do is lift that router bit off of this safety block by hitting the up Z button. Pull that block out, set it aside. The next thing is to put in a spoil board, since we know that we'll be cutting all the way through our job, and we don't want to run into the base of the material. So first put a spoil board, a protection board in there, and then the board that we're going to run the job on, our good piece of material. Set that on top of the spoil board. I've also got this spacer that I'm going to put up against this rail here on the left side. The way I've set this machine up is that this rail runs exactly parallel to the y-axis, but it's also put in such a position that the router bit won't run into it. So I have to space over to actually run a job. So we'll put that in there, and then we'll clamp down our material in the front and in the back. Try to get at least 2 points clamped down, then we can remove our spacer. I'm actually going to move this clamp over just a little bit to make sure that it's out of the path of the router bit, still maintaining that position. So we've got our material clamped in there now. There's already one key cut here. I'll be running another one next to it, so I've put a point there where I want my X and Y 0 to be. So just like in this case, we're going to be running multiple keys out of the same piece of material. In order to establish that 0 for the X and Y axes, we'll move the router bit over until it's just above that point. Do that by using these jog keys again. So first we'll move left, so it's as if you're facing the machine from this direction. Left, down, near, a little more left. And now that I'm close to that point, there's a button here that says fast. So the movements that I was just making are in the fast speed. I'll hit it once, it goes to medium. I'll hit it again, it'll go to slow. Now I can move down without worrying about actually running into the material. I'll go down slowly and near. Away just a little bit. Away just a little bit more. Okay, so now there's just these random dimensions relative to where the router bit was when I turned the control box on. But this is the point when I want to set, at least for the X and Y axis, zeros. So I'm going to say 0, X, Y, and Z. It warns me that I'm about to change the 0 point. I say OK. Now, where that point of the router bit is where X, Y, and Z 0 are established for this job. So X and Y are good. I'd like a little bit better knowledge of where the surface is. So there's a touch plate that's available for this particular operation. We'll get that out. We'll move the router bit up out of the way a little bit with the jog it up in the Z direction fast. Get it about that far above the material. Then we'll place this touch plate underneath of the bit, connect the magnet to the collet area. What will happen here is when the router bit touches the touch plate, it'll complete a circuit, and the machine will know precisely where 0 is because it knows the exact thickness of this plate. So we have that kind of underneath the bit now. We're going to hit the button that says plate.
It says prepare for touch plate, tool bit must be above the material. Connect the touch plate magnet to Z. We did that here. We say OK. Now it wants to make sure that there is indeed a circuit, so it has you touch the bit with the touch plate. It turns red to let you know that we have a circuit. Put it back underneath the bit, press OK to begin. So now it's going to move slowly down. Make sure you don't have your fingers in there. And as soon as it touches the plate, it'll establish that distance and it'll retract a certain distance. You can remove the touch plate, and now we've zeroed in the Z direction as well as the X and Y. Accept these results, OK. So right now the tip of the bit is sitting at X0, Y0, and 5/8 of an inch above our workpiece. That's all good. So we've done the zeroing. I'll go now to the checklist, and even though we've done all the steps, I'd like to go through and make sure that, just to double check that everything is safe before we begin. So material dimensions match our drawing. That's good in terms of where I've established the zero position. The spoil board is in place for when we cut through the material. We are clamped securely and out of the tool path. The router is plugged in, and we're going to flip the switch on the router to make sure it's turned on. I have the speed I want set on the router, and I have the bit in the router that I want. As far as referencing, X and Y I've established over top of that pencil dot, and I've set the zero height using that touch plate. Proper start position and Z gaps. So those are within the file itself. So I'm gonna, in order to look at those, I will hit the USB button. This will bring up a listing of all the files on that USB. There's only one, the key for training file that we created earlier. I'll tap that. And then it shows me information about that file. When it was created, it verifies the material dimensions, where the origin is, where the home position is, what the safe gaps are above the material when it goes from one cut to another. I can go down the screen here and see that it's going to cut both the logo and the cutout, and it's going to use a 1mm ball nose. That's all good. So we'll say next. This is a screen for another utility called Virtual Zero, but we've already done the zeroing using the touch plate, so we don't need to do this. So I'll say do not use Virtual Zero. At this point, we're ready to go. Well, as far as the rest of the checklist, dust boot is on. That is this. I won't be using this so that you can see better how it's going to be cut. We're not going to create a whole lot of dust out of this operation anyway. The shop vac does not need to be on, a dust collection system. Hearing protection, I have my noise canceling earbuds in, and room fan, I have my safety glasses on. So we're good to go on the checklist. So what it's going to do, it's going to go in and first do a pass to cut out the logo, the Habitat logo. When it's done with that operation, it'll then cut out the key all the way around. It's going to get kind of noisy, so I'm not going to be doing any talking during that point. So here we go. The CNC machining operation begins with pocketing out the people part of the Habitat logo. I've speeded this up a bit because it takes a little while. After it finishes the people part, it moves on to the roof. The roof is actually a cutout operation because we're going to use this roof and the little opening that it has there in order to hold the key ring. So it's going to take 3 passes to get around that roof. Next, it moves on to the outer profile of the key. This is also going to take 3 passes, but I removed one of them in the middle, so we're only going to see 2 of those passes for the cutout operation. As it goes around, when it comes around this next corner, you'll see it lift up and go over to create one of those tabs. So now it's actually on the 3rd pass, making its way around the profile to finish the cutout operation for the key. So at the end of the operation, the router spins down, turns off, and I also like to turn it off here at the switch just to be safe. And we can
hit on the pendant, we can hit stop, and then X and exit. Now we're back to the screen with the jog buttons. I can jog it out of the way, let's say over here to the right. And unclamp. You may remember that we left some tabs in there so that the material did not work itself loose. We'll go over and eventually cut those tabs out with a chisel, and we can do some cleanup with a little wire brush to kind of clean out the logo there, and eventually just maybe sand it down just a bit to be done. And then it'll release the key, and we could do a whole board full of these if we wish to, but there at least we've made one of the keys and shown all the steps through this operation.
In the video up to this point, I've tried to show all the steps necessary to complete one specific project, a habitat key. I mentioned at the beginning though that the video that I've prepared is part of training for some co-workers at Habitat for Humanity. That training is going to include some still slides like the one you see here. I'm just going to step through these in case any of these are useful as reference material. So here we're pointing out that we are featuring the VCarve desktop version 11 software for the drawing, and also the Next Wave CNC Shark 2 for the actual machining. The next slide shows some of the example things we've made with the CNC for Habitat. We move on to show the old versus the new process, the old process using a table saw and a router versus the CNC machine, then the workflow that's involved in doing a CNC project. This slide highlights the Vectric software that we're using, including some links for various product descriptions, trial downloads, a tour of the free trial, and some training videos. You won't be able to click on the links in this video, but my intention is to make them available in the description below the video. Here shows an overview of the VCarve desktop user interface, just the various sections, and then the video that you just saw will talk about how the drawing was actually made. Then the transferring of the toolpaths to the CNC flowchart, the router components. Again, you can pause the video at any time to look at these in more detail, and then machining the part, the flowchart for that part of the operation. And then an appendix with some reference material, a glossary for what I call the language of CNC routing in case some of these terms are unfamiliar, some router bit types shown here, the collection of router bits that we have at Habitat for Humanity and also at Flash Tracks Woodworking, then how to select a router bit using the VCarve desktop software, and then a little discussion on feeds, speeds, and chip loads. It shows the equation for the chip load calculation as well as the inputs that go into that calculation. This slide shows that just taking 4 nearly arbitrary tools out of my tool catalog shows that my average chip load usage is about 1/1000th of an inch. Makes a decent starting point for moving up or down from there depending on the bit and the application and some of the factors that are going to affect the selection of the chip load and some of the speeds and feeds. A safe operating procedure. I find this handy to keep at the machine itself just to make sure no mistakes are made. And then some additional safety and protocol considerations. Some care and maintenance for the CNC machine. A little discussion on what Virtual Zero is, which is a somewhat special feature to the Next Wave automation product. And then a little discussion on vector versus raster and why you want to try to use vectors or import vectors whenever you can to be compatible with this software. Then some reference videos, which is basically the playlist at Flash Tracks Woodworking and some different applications for the software as well as the machine. And then finally, thanks for watching. Leave a comment below, ask a question, give it a thumbs up, subscribe if you like. In any case, thanks for watching, and come back soon to the next installment of Flash Tracks Woodworking.